Right, let's take a look at the review questions. Okay, so here we go. Question 1. We are going to use this formula, that A equals P, 1 plus APR with Y as the exponent, okay? So here we go. So P is 30,000. 1 plus, now remember, we're decreasing here, so it's going down by 12%. So that actually should be, of course, minus there. So minus 12%, which is 0.12. And we're doing it for 6 years. Okay, so that needs to go in the calculator. Right, bear with me. Okay, so 0.88, that's 1 minus 0.12, to the power 6 equals times 30,000. We get, I think, remember this, we get 13,932 and 12 cents. Okay, right, let's look at the next one. Population 500,000, doubling time of 20 years. Right, remember this? It's a doubling time one. The doubling time is 20 years. We're looking for it in 7 years, and it starts off at 500,000. Okay, so that's what we're doing. So 2 to the power of, what's that? 7 divided by 20 equals times by 500,000. I think that's 637 and 280. Hopefully I don't make any mistakes in here. Okay, next one. Would you rather start with 1 penny and double your wealth every day for a month? Okay, so again, you start off with a penny. If this is doubling time and you do it for 30 days, that's what you would do. Okay. Now, if you start with $100 and you double it every other day, every 2 days, that's only 15 doubling times. But you could think of it like this. Remember, 2. If you're going to double it, if your doubling time is every day, that's still 2 to the power 30. Okay, 30 days in a month. But if your doubling time is every 2 days, then that's where the 15 comes from. Okay, so therefore, just put those in your calculator and figure that one out. Right, population growth rate of Poland, estimated 1.2. This is this. Remember, the doubling time, T double, equals 70 over 1.2. That's all it is. Put that in your calculator, and that will be the doubling time. Okay? Now, half-life of Ritalin, bloodstream, 4 hours. Ritalin left in bloodstream. Okay, so this is a half-time one, so we're doing half. It does say the half-life. Okay, so again, this is the denominator of the exponent. Looking after 14 hours, and we start off with 10. Okay, so that's what you're going to put in your calculator. I'll run through that one. Okay, so 0.5, raise that to the power 14 over 4. 14 divided by 4. Okay, hopefully it's that, times 10 equals, and that equals 0.88. It is quite small, because it's halved to 5, it's halved again to 2.5, it's halved again to 1.25, half again. So that's what you're getting down to. Okay? Right, let's look at the next one. China, 1.5 billion people, growing at a rate of 0.7%, population in 40 years. Okay, so this is one where you need to know the doubling time. It is like going back to one of the previous questions where it gave us the doubling time, so we could put it straight into the formula. Okay, we could just put it straight into this. Okay, now we know that's 40 years, but we don't know what the doubling time is. So remember, we're going to do that. Remember the approximate doubling time formula? Now that will give us 100. So I'm going to put 100 right at the denominator. So 2. 40 on top, 100 on bottom, and we start off with 1.5 billion people. That's what's going to go in my calculator. So 2 with an exponent of, what is that? Is that 0.4? And then times it by 1.5 equals. Okay, so about 1 point now, which is about 1.98 billion people. Okay, that's what you get. Now, question 8 is going to be very similar to question 7. It's the half-life one instead. Okay, same kind of question. We've got to figure out what the half-life is in terms of years for this one. Again, it's 70. Oops, that's not 70. 70 over 0.005. Okay. So what's that? 70 divided by 0.005 is, remember, that was 14,000 years. So that is the half-life time, not the doubling time, but it's still the same kind of formula because we're going to plug it into here. Remember? That is the denominator in the exponent. We want to look for it in 10,000 years, so that's the small t in the formula. remember, like up here. And we start with 100 grams. Okay, so again, so remember, this is the exponent here. Right, so let's try this calculator again. Half, right, 0.5, raise it to the power of 10,000 over 14,000. Bear with me. What was that? Hope I've done that right. Times 100. 60, okay, so about 61. About 61 grams, 60.95. Hopefully I've done that right. Okay, so there you go, because it's going down this time. It's decaying, so it started at 100, went down to 61. Right, okay, so last question. Okay, where are we? Let's just erase some of this. Right, China, 1960. Now, okay, try and remember this. Remember, I can explain this like this. All right, if this is, let's say, something like 2% and it keeps on going, it'll keep on going up. But in reality, we start to slow down, and you get to a point where you can't fit any more people on the planet. Okay, and whatever that number is the carrying capacity. Okay, so this is what happens here. At any point in time, let's say here, then the actual base rate we've been basing this off is actually dropped to something less. This is the logistic growth rate, okay? This was the base one. Okay, that's what it is, okay? If it wasn't slowing down. This is the logistic one. Okay, so right now we have a logistic growth rate of 1.8%. Now, if you remember the formula, it was the logistic growth rate on top, and I'm going to use this. If you want to change that to decimals, you can do. You'll only go back to where you started. Okay, so this is me calculating the base growth rate R. It's 1 minus, now then for 1960, that was 670 million, and the carrying capacity is 2 billion, but remember, that's 2,000 million. You've got to have them the same, millions, you can't put a 2 there, that's billion. So, let's take a look at that in our calculators. Right. Okay, so here we go. 6. You do it how you can. Okay, I'm doing it my own way. Do that. 2.7. I get R is 2.7%. Again, remember the base growth rate is going to be bigger than the logistic one. Okay, because this is the one where it started to slow down. Okay, so we now have got an R equals 2.7. So the other formula, which is a rearrangement of the one I've, just check on the top of this paper. I know it's not on here, but on the paper that I handed out, or that I emailed everybody. Okay, so for the formulas. Right, so here we go. So it is 2.7 times 1 minus, again, the population over the carrying capacity. And this time, all down here, this time it's 1.4 over 2, okay? So that's the other formula. Again, check at the top of this paper. Okay, so we have 1.4 equals, whoops, 1.4 divided by 2 equals, okay, times 2.7, I get 0.81, okay, what we're looking for. We've got the base growth rate there, we found it 2.7, and the current logistic growth rate, I get it to be 0.81%, okay? Right, those are the questions. I might do this one differently, not give us extra credit, but in other words, I'll make it easier. You've just got to figure out by using one of the formulas, just throw the numbers in, whereas this one, you kind of had to use that one, then that one, and it was a bit more work. So anyway, those are the questions if you want to do the test on Thursday or Tuesday next week.